Hello everyone, here I am Varel Sagar and welcome back to the part number 19 of the present discussion. Let us start. As we know, in the part number 11 we seen the first 7 exercise examples, and today we go for the 1.8 is the first, and then maybe up to 14 some today we will discuss, and the next few in the next session. Okay, 2-point charge QA and QB, 3 microfarad and minus 3 microfarad. They are located at the 20 centimeter apart in a vacuum. Okay, this is a discussion what it is given. What we have to find, what is the electric field at the midpoint at the line of joining of AB and these two charge, and after that we will see the what the B task it is there. Okay, for the A, so plus 3 microfarad minus 3 microfarad, they are separated by the 20 centimeter distance. This is a 20 centimeter. For your calculation you have to take your 0.2 meter. Okay, whenever you have this. But what is the asking point, what is electric field at the midpoint? So our observations is all over the happen at the midpoint. So the this charge to the this is distance is 10 centimeter, and the 10 centimeters is the in for our calculation it will be 0.1 you can use, either you can go with the 10 into 10 to the power minus 2. Okay, so there is a two charge, one is negative charge and one is positive charge. Both are generating electric field on the point number O. So even electric field along the OB direction, why? Because it's the negative, so it is a this directions, it is invertly O to B directions, where our if I write the even electric field due to one charge, there it will be the Q upon 4 pi epsilon 0 R square. This is the fundamental electrical field formula. Then the charge is 3 into this C. Charge is whether negative or positive, it has charge. Negative, positive for our convenience. So here the no bothering to the positive, negative, they are taking 3 into 10 to the power minus 6 because of the micro, 4 epsilon 0, 10, 9 into 10 to the power 9. At the end you have to calculation, this is here, and they are taking the 10 into 10 to the power minus 2. That is clear to you as a above discussion. This distance is 10 centimeter and centimeter converted into the meter, so the 10 into 10 to the power minus 2, and the square R square it will be square. Okay, and the electric field is Newton per Coulomb. That is a fundamental unit is also. Okay, so now I am just putting the values respective the sides, and why I am taking the mode, because the actually as I said is the negative, but the negative will be not considered, so that is the explanation how it takes a positive. This is the it may help you in a board examination. Suppose you are going to be 90 plus marks, then such type of kind of things are cares there. You are taking mode and then you are saying something, there is the negative sign is just for our conveniency. At the end you at the calculation point of view their minus sign is not considerable. So this is the E2, it comes by the electric field by B particles, and this electric field due to first particle plus 3. Okay, but again it will be the plus for you. So the one electric field, second electric field, both charges are generating electric field on the point O. So that total electric field E is equal to E1 plus E2 on O particle. So the 2 time, because both are same and just minus plus it is, so the 2 time of 9 into 10 to the power 9 is means below the 1 upon 4 pi epsilon 0. Actually it is a K, it's above side K, so it will be the 9 into 10 to the power 9. X multiply 3 into 10 to the power minus 6, which is a 3 microfarad charge, and this is denominator is a R, 10 centimeter. Okay, then if you do the calculation in your calculator, you will get the 5.4 into 10 to the power 6 Newton per Coulomb along the OB direction, resultant one. Why? This is positive charge, so along the AO, and this is a negative charge, so along the OB, so resultant this direction, this is the OB direction, either you can say A to B direction, but actually it is a A from to 0 or A to O to B, so ultimately O to B is the resultant direction. Okay, so what is the B task? Let us see first of all the question. if the negative test charge of magnitude 1.5 into 10 to the minus 6 is placed at this point, okay, at the O point, now we are putting one charge, 1.5 into 10 to the minus 9 coulomb it has. Now what force feel by the test charge? Okay, let's go. Okay, so that Q is equal to 1.5 10 to the minus 9 charge is present. Then what is the force? It is called test charge. F is equal to Q time E. That is a very fundamental equation. That our Q test charge, where nu Q, how much force feel by that two other charge which are present on the either sides. 1.5 10 to the minus 9. The two other charges which are 3 microfarad on the one side and 3 minus 3 microfarad on the one side, they are generating electric field you already found. So this electric field you can use 5.4 into 10 to the minus 6. You will get the force field by that centriole charge 8.1 10 to the minus 3 Newton. This is the directed towards to the OA. This is because this is a resultant electric field in this direction, the always force in the opposite direction. This is because the negative test charge is repelled to the charge to the B and attract towards to the A, so towards to the OA directions. This is what we have in the 1.8. Let us go for the 1.9. A system has two charge QA and QB, respective numbers. You can able to see that located at the distance of the coordinates minus 15 centimeter in the Z and the plus 15 centimeter in the Z on the B particles respectively. So what we have to find, what are the total charge and electric dipole of the system. So the Q and P we have to find. Okay, this is what we have in the Z directions plus 15 and the minus plus Z direction. Minus Z direction, it means point A is staying in a positive Z directions, the B particle is staying, but both are at the 1550 degree centimeter. Then you may found out as a number lines idea at the 0 to the positive 15 direction and 0 to negative 15 direction. The total distance between them, between two charges, are the 30 centimeter. So this is what idea we have to take from this coordinates point of view. They are not giving the direct distance between two charge. So this is from the coordinates we are getting the informations of R, distance between two charges, and the two charges are the summation of the total charge system is equal to 0, because the one charge is negative and one charge is positive, in equal in amount, equal in magnitude. So the total, this is the first task, total charge of the system is 0. So the first answer is 0. Second is electric dipole. P is equal to Q time D. As you know, that is your what the total charge it has time multiplied by D. So D is the distance between them. So the 2.5 to 10 to the power minus 7, it is a charge, one of the charge you can take. When you have both the charge is same, then this kind of question comes into pictures, and the distance between them is 0.3. Why? 30 centimeter, as I explained you, 30 centimeter in the meter is a 0.3 meter, and then answer of the dipole moment is 7.5 into 10 to the power minus 8 centimeter, coulomb into meter, because the Q time D. Okay, this is what we have in the 1.9. Let's go for the 1.10. An electric dipole with the dipole moment is this. Okay, I am going in a very express way. You can pause, you can write, you can understand, and go for the next example, but I have to complete it within some time limit. So one dipole moment is given, which is aligned to the 30 centimeter with the directions of uniform electric magnetic field. So this is a very easy to understandable. When we discuss dipole moment concept and dipoles concept, there is a one particular directions. Okay, suppose this is the directions of electric field, and dipole, suppose two charges is, one charge is here and one charge is here, so dipole moment somewhere in this. So this dipole moment direction, this is electric field direction, this makes an angle. Are you getting what I am trying to explain you? Okay, so this is the 30 centimeter or 30 degree angle they are constructing. Calculate the magnitude of torque. So torque, we have to find the torque of dipole moment. You may come across with this during the chapter. So very easy example for you. P is given, Q is equal to 30 degree centimeter is given, E is given, the torque is equal to P cross E, and cross product is reduces to the sine theta. Then it will be just putting the numbers, and the sine 30 is 1/2. Then you are reduces to your direct answer 10 to the power minus 4 Newton into meter. So the torque feel by the dipole due to the electric field which are present to the at the angle of 30, 10 to the power 10 to the power minus 4 only force field. Actually, torque is nothing but the one type of force, but the cornea force, it means angular force. Let's go for the 10.11. A polythene is you have piece rubber with the wool. So polythene piece rubbed with the wool. Two things here you have: polythene you have, wool you have, is found to be negative charge. So the wool, when you are rubbed there, you are found out the negative charge 3 into 10 to the minus 7 coulomb. A task is estimate the number of electron which transfer from the one side to the another side, either the polythene to the wool or wool to the polythene. How much? Estimate this. And the B task is there is a transfer of mass from wool to polythene. It can be possible. From the wool to polythene, mass can be transferred. Mass is nothing in the sense of electron, because electron has mass. So the electron can transfer, then you can able to say that is the mass I can transfer. Okay, let's go for the A task. When the polythene is rubbed against the wool, a number of electrons get transferred from the wool to polythene. That is clear. Hence, wool becomes positively charged and the polythene becomes negatively charged, because the polythene gets electron from the wool. So the negative charge once you get, then you are getting a more negatize. Then that you are going to be, it means polythene. If I'm assume myself as a polythene and you are as a wool, then we are rub each other's, then I am getting a negatively charge and you are getting positively charge, because you are losing the electrons from your side. Amount of charge for the polythene is given in the sense of the negative charge, so that's why I'm taking the minus 3 into 10 to the minus 7, as you can see in a yellowish line. Now onwards, I'm not disturbing the screen. This is a highlighted point is given. Amount of charge is electron is 1 point. Okay, that you were able very well known. You know, very fundamental is the charge Q is equal to quantization's formula from this. Q is equal to NE and N is equal to Q by E. The Q is given, E is given. You will reach to your answer 1.87 10 to the power minus 12. 10 to the power 12, sorry, not minus. This is the number of electron that transfer from the wool to polythene. But now second task B. Okay, that is your second task question, and then the answer is yes. Then it is transferring the mass of electron. One electron mass is 9.1 10 to the minus 31, and how much electron transfer? A 1.87 10 to the minus 10 to the power 12 number. See, this answer never it can be negative, because it's a number. So that one, if you have a if you are doing calculation and you are end up with the one negative sign of power, then you may conclude that your answer is wrong completely. Okay, this much number of some number 10 to the power 12, some number of electron you have, and one electron has this much mass, then the 2 3 4 5 6 electron you have, no, 10 to the power 12 number of electron you have, multiply with this one electron mass, then the total mass can transfer from the wool to polythene is this much, 1.706 into 10 to the power minus 18 kg, and that is very negligible. So you are not feel like મેં બધું પેલાને આપી દીધું. If you are we are rob each others, you not feel, oh, I'm just giving the 2 kilo mass to you. No, you are just transferring of thousands of 10 to the power 12 electron. Still you are not giving even though 1 gram. It is just minus 18 kg. This is very small number. Hence, a negligible amount of mass is transferred to the wool to polythene. Okay. This is a task number 11.12. You can take breath between it, but I have to go. The two insulate charge copper sphere A and B have their centers separated by the distance 15 centimeter. You can see the two charge sphere, which is charged by QA and QB. This is separated by the 50 centimeter, is reduces to 0.5 meter with the mutual force electrostatic repulsion of that, because the both are similarly charged. Each other 6.5 to 10.7 is the charge. Both are same charge. The radii of A and B is negligible compared to the distance, so there is no make much matter. Whatever the 0.5 is given, you have to take as consider as the r distance between them. And what is the task now? What is the mutual force we have to find? Okay, the charge on A is QA, charge on B is QB, which is nothing but the 6.5 to 10 to the minus 7 coulomb, and the distance between them is of 50 centimeters, is reduces to the 0.5. and well-known Coulomb's law, F is equal to Q1 QB QA QB upon 4 pi epsilon 0 R square, where F is equal to 9 into 10 to the power 9. This is nothing but the, if you want to write, if you don't want to write in this way, you can write directly K Q1 Q2 upon R square. The K value itself is 10 to the power 9. So no need to write, repeat every time these things. 10, 9 into 10 to the power 9, 6.5 10 to the power minus 7 raised to square. Why? Because Q1, QA and a QB all both are same, upon 0.5 raised to square. Do the calculation in your calculator, you will reach to the 1.52 into 10 minus 2 Newton. That is very important. You must complete it with the unit, otherwise you may lose few marks in the lake of unit. Okay, this is the one task is given. Now B task in the same question, what is the force of repulsion between them if your charge is going to be double, then your distance is going to be half of it. So that QQ, it means whatever the 6.5 number given, it going to be double, and your distance between them is your 0.5 meter is going to be half. It means you are taking now onwards at the 25 centimeters. Okay, let's go for the calculation point of view. After the doubling of charge, the 2 time of 6.5 into 10 to the minus 7 is the 1.3 into 10 to the minus 6. This 1.3 into 10 to the minus 6 is the charge on each charges, 2 charge you have. So this will be the, at the end you will be get a square of it. This is 2 time. Okay, and the R is 0.5 to going to be half, as the question said, so it will be 0.25. So you may have to squared at the end 0.25 square instead of 0.5. So again that F is equal to K Q1 Q2 upon R square. That Q1 you know, it means QA or QB you know, 1.3 in 10 to the power minus 6. R you know, put the respective values and you will reach to your answer 0.243 Newton. Thank you. Okay, the 1.13, it is not a completing session. 1.14 is the last one. Suppose that again now same exercise, A and B has idealized size, then third will come into pictures, then A and B is there. Again, sorry. Both charge is there, they are separated by also, and then third party will come into picture. The third object will come, bring into screen, and which is uncharged also. So what is the task now? Please trying to explain or trying to understand this. A third sphere which is here of same size but uncharged is brought into the contact with the first one, this one, then in the contact, then after it is also contact with the second one, and finally removed from the system. Then what is the charge or what is the force between the A and B? This is only what happening. Again I am removing this screen because you have to understand first. Okay, it is a first particle and this is a second particle for you, and this is a third particle for you. What happening and what you have to do actually? First you have to bring third party into the contact with it. It means what the total charge on the first one, Q. If you are brought into contact with the uncharged system, then obviously the charge will transfer on the uncharged system and they are getting a equalizing the charge. So it is a charge transformations happen. If this Q is there present on it, so after the contact and after the losing the contact, they both have a now Q by 2, they are getting a half. So that it will be going to be reduction in the charge system. So it will be Q by 2. Now then after this, the third one is come into the contact with the second. How much charge? How much charge it has? Q charge. And what is the charge it is on the third system or the third sphere? Q by 2 is already have, which is gotten by the A particle or the A sphere. Now what is the total? Because you know both are comes into the contact and they are getting a nullify each other, and then they are transferring half of charge. From where to where the charge transfer is happen is the high side to the low side. Let's start what to do. That is what the basically it is given. Now this is what I explained. A and C will come, so they are giving the name A, B, and this is a C, and A and C comes into contact, so this will be Q by 2 comes into picture, and this Q by 2 of this charge, now it comes to the contact with the B, which is a Q. Now the what first of all you have to do after before you are half before you are judge what half charge transferring on the C and B. Before that you may clear about what is total system charge. Once you are bring a contact between them B and C, what is the total system? Because the B has Q and C has Q by 2, so what is the total? So this is a Q by 2 plus Q, it's a total, it's a 3 or something number, and divide by 2, which is nothing but your total charge, which can be happen after the losing contact between them B and C. So now onwards B has charge 3q by 4. This is a very crucial part of this discussion, actually very easy. Again I am explaining what is the charge on the C sphere, q by 2, and what is the charge on the B sphere is a q. Okay, now when they are come into the contact, they are always just see the B sphere has q and say C sphere is q by 2, so it is a not a same charges. It means that there the charge transformation can be happen. Okay, now the q B sphere has more, obviously B sphere has more, so the charge transformation from here to here it will be happen. But how much? Up to what limit? Up to what time it can transfer? So for this question answer, you have to know about total system. What is total system charge? What is the charge on B? Q. What is the charge on C? Q by 2. So the what is the total? Q plus Q by 2 is the 3Q by 2. This is the total charge, and after the equilibrium condition is the nothing but the half of both of the 3q by 2 divided by 2, it is nothing but the 3q by 4, and this is the charge on the each B and C. Now the C will be get lost from the frame. Now A and B only stay there. What is the charge on A? Q by 2. What is the charge on B? 3q by 4. Now find your question same. Okay, so now this is the what the q1 q2 upon r square, kq1 r square. This is your k 9 10 to the power 9 3 time 3q by, it is actually 3q in q by 2 3q by 4. This is a qa and qb. Put the respective values and the reduces to the some conclusive way. So you may found out the 3q square. See, you can do your maths here. I cannot explain the all things in the videos. You can able to see that is pure math steps are there, but at the end you have to put the respective values. I can explain you one thing. K q1 q2 upon r square. K is 9 into 10 to the power 9. Qa is the q by 2. QB is equal to 3q by 4, and where your q is 6.5 into 10 to the power 9, 10 to the power minus 7. Put the all values where your r is 0.5. Now onwards it's your math step. Okay, 5.703 in 10 to the power minus 3 Newton force will be there. Okay, let's go for the 1.14. Now the see this without read that above question. You have a two plates, one is positively charged and one is negatively charged, and the system the charge particles are transferring from the two plates. The first particle, second particle and third particle, the first two particle 1 and 2 are deflected towards to the positive plate, and the third particles is deflecting towards to the negative plates. So we have to judge in this question, we have to judge the what is the charge on particle 1 2 and 3. As per our common sense, the particle 1 and 2 is the deflect or repel from the negative terminal. You can see the 1 and 2 is the attract towards the positive side, and the another way I can say it repel from the negative side. So the 1 and 2 particle has it has to be charged positive negative charge, because it's the repel from the negative. So both should be negative, then it can be similar charge is always repel. And the third charge, it has to be attract towards to the negative side, and then it should be positive charge, then it can be attract towards to the negative plate, and it repelled from the positive side, so it has to be positive. So I can judge without reading the answer of its 1 and 2 charge has to be negatively charged, and third charge should be positively charged. Now you can read by pausing the video, or you can read the highlighted parts. I explained the first paragraph, and the second paragraph is a charge. And yes, one more conclusion from this, you can see the first and second charge is deflecting slightly from the original trajectory. This is the original trajectory. It can go, if it is the plates are not there, it can go in this direction, but it deflects towards to the positive side. And the second also same, maybe minimally, or the it is a looking similar way deflection. But the third is deflect very much. What does it mean? It means the highly deflections is shows it is a more charge it has. If you have more charge, you feel more electromotive force. I can remind you, F is equal to Q time of E. You may feel force, F is Q time of E. So Q, if your charge is more, then you may feel force is more. So you are more deflection is can be happen by the more force. And when it can be more force, when it is a more charge. So I can judge at the end also without the seeing this picture. Not only I can judge what the charge it has, I can judge the magnitude scenario. The third will be the more charge than the 1 and 2. Okay, this is what we need to discuss today. Thank you very much. If any kind of difficulty, or the for the understanding point of view, or any way you have a query, you can ask in comment sections. And also